All right, ladies and gentlemen, welcome to your math class for today. Today we're going to talk about graphs of equations. So I'm going to just go over the two examples that we did in class today, and hopefully this video will be a good resource for you to do the homework assignment. So today we're going to talk about graphing linear functions, and we are going to see it from two different perspectives. We know that a linear function has the formula of f of x equals x and also we can say f of x equals y equals mx plus b. Now remember that if in your book instead of seeing f of x you see y, it doesn't make a difference because f of x and y actually mean the same thing. Okay, so if you have this, now we're going to start with a parent function. Now a parent function is kind of like it's the original function. In fact, I'm going to read the definition of what a parent function is according to your textbooks. Okay, so give me 1 second while I look for the page and I can read the definition to you guys so we're on the same track of what we're doing. So basically a parent function is a group of function with shared characteristics. So f of x equals x, or f of x equals mx plus b are parent functions. And what they do is that the graphs that are similar to them share the same characteristics. So let's look at this. Let's see what the graph of f of x equals x looks like. And what we're going to do is we're then going to do one of the examples and compare them. So of course, if we go to our basic graphing concepts, you know that we have an x-axis, which is the horizontal line. And we have the y-axis, which is the vertical line, okay? So if we have f of x equals x, and we're going to compare it to f of x equals mx plus b. So the m here refers to slope, and the b refers to the y-intercept. So the y-intercept, now before I get into graphing y f of x equals x, let me explain what m equals. M is the slope, okay, and b is the y-intercept. You can understand that whenever you have a y-intercept, in the y-intercept, x always equals 0. Okay, so in the what bm is my slope, b is my y-intercept, and always remember that whenever you have the y-intercept, b, whenever you have the y-intercept, x is always 0. That means, what that means, I'm sorry, let me see if I can bring this down here. What that means is that x, or that the y-intercept, is going to be an ordered pair with 0 and whatever number b is. So in some books, you'll see it as 0b, where what I'm just trying to say is that the y-intercept is going to be, or whenever I have a y-intercept, x is always going to be 0. So you're going to have an ordered pair that's going to be 0 and something. And the slope is m, and sometimes, or that slope is always going to be represented is a representation of y over x because of the slope formula. So the slope is always going to be in the form of a fraction. Now let's graph this and then start comparing it. So if I look at this graph right here, or this function f of x equals x, I know that the slope is actually going to be 1. And the reason that the slope is going to be 1 is because, remember, if there's no number in front of the variable, we assume that that number is a 1. Or another way of saying is, how many x's do I have? Well, I only have 1 x, so that's why the slope is 1. If I look at this function of f of x equals x, I don't have a b. I don't have a y-intercept. So what that means is that the y-intercept equals 0. So that means that the first ordered pair that I'm going to have in this function is 0 and 0. So the next thing we're going to do now is just graph them. Okay. Now I'm going to leave this here and graph this. And then when we do our examples, I'm just going to leave it expressed. So all I have to do is look for the ordered pair, my y-intercept, which is 0. Hence, the first ordered pair is going to be 0, 0. Now, how do I graph my second ordered pair? Well, to graph my second ordered pair, I have to look at the slope. So the first thing is that whenever I'm graphing a linear function or linear equation, I always graph my y-intercept, because that's always going to be my first ordered pair. In this case, that ordered pair is 0, 0. Now, to graph my second point, I'm going to look at the slope. M is 1, right? So I said that the representation of a slope is always y over x, which means a fraction. So even though 1 is technically a whole number, I know that it's a rational number, so I can express it as a fraction of 1 over 1. Now, what does that mean in terms of what I have to graph? Well, if 0, 0 is my origin, and y, remember, the numerator is y. Whenever you're working with slopes, the numerator is y and the denominator is x, or rise over run, like we did in our previous class. And you can go ahead and review those videos if you need a reminder of that. So what that means for this graph is I'm just going to graph. I'm going to move from the 0, 0, 1 space up. Let me change the color so that you can see what I did. So I move 1 space up and 1 space to the right. So that means that this is my graph for y equals x. So this is my graph for y equals x. So this is the graph for y equals x, okay? Now we're going to look at example number 1. And example number 1a, to be exact, I can do it down here. Example 1a, let me go change the color again. Example 1a, so this is example 1a on page 89. Example 1a on page 89. So example 1a on page 89 says, graph the function y equals 2x and compare it to y equals x. So y equals 2x is what I'm going to graph, and they want me to compare it to y equals x. Okay, so y equals 2x. Y equals 2x. So the first thing I want to do is I want to find my slope and find my y-intercept. Well, my slope is 2 because it's 2x, right? And remember that the slope is a representation of y over x. So in reality, I write this as 2 over 1. So for graphing purposes, so remember my numerator is y. And my denominator is x. So y over x. And you don't have to do that every time. I'm just labeling it so you guys can see what I'm doing. And the slope, or the y-intercept, excuse me. Do I have a y-intercept? If I look at this equation says f of x equals mx plus b, which means that there's a y-intercept. If I look at example 1a, it just says y equals 2x. So there's no y-intercept, which means that b, the y-intercept, is 0. And if the y-intercept is 0, that means that the ordered pair that I'm going to have is also 0. So that would be 0, 0 as my ordered pair. Okay, so now that I have all the information that I need, I can graph and I can compare. And what I'm actually going to do is I'm actually going to graph it right where I graphed y equals x. so that way we can compare it. Let me just change. First of all, write this as y equals x. And now I can graph my second function. So y equals x. Now I'm going to change the color again. I'm going to use red. So the y-intercept is the origin, so it's also 0, 0, which is right here. Now the slope of this graph is 2, so that means that from 0, 0, I'm going to count 1 and 2 spaces up, and I'm going to count 1 space to the right, which is here. So basically, the graph here would look kind of like this. So the red graph is y equals 2x. And the blue graph is y equals x. So y equals 2x. And that the problem is asking you to compare. Well, when you compare it, the difference is that, well, y equals x has a slope of 1 and y equals 2x has a slope of 2. So the difference is in the slope. Again, y equals x. This is the difference. That's why they're asking us to compare. Here, the slope equals 1. And in y equals 2x, the slope equals 2. And because the slope equals 2, that's just the main difference. Okay, so that's how we do example 1a. Just graph them, compare them. Example 1b is pretty much the same. It's just that we have a different formula. For example 1b, the formula is y equals x plus 3. So let me just kind of go ahead and start erasing a little bit of these things to have more space. I'm going to leave the y equals x formula. So let me see if I can erase this. There you go. And this. I'm going to erase this real quick. Okie dokie. Let me erase this as well. I'm going to leave the y equals x, the information for y equals x, because the second problem asks me to compare it as well. So I'm just leaving it there as a basis for comparison. So the second equation is y equals x plus 3. So yeah, this is 1b. 1b. And it says y equals x plus 3. And we're going to get the information that we need and then graph it. And at the end, we're going to compare it to y equals x. So y equals x plus 3. The slope is 1, right? Just like it would be in y equals x, because since there's no number in front of the x, you assume that the slope is 1. And remember that if the slope is a whole number, we write it as 1 over 1 because that's going to help us graph, okay? So that's why I wrote this as 1 over 1. Now, if I look at b, b is my y-intercept. Now, whenever I look for a y-intercept, remember that x is 0. So this is actually going to be an ordered pair where x is going to be, the y-intercept is 3, right? Let me first write that down. And then the second thing I'm going to do is, once I know my y-intercept, is write my ordered pair. Now, as I was saying, because the y-intercept is 3, that means the graph that touches the y-axis at specifically at 3, so x has to equal 0. So the ordered pair that I'm going to have is 0 and 3. Now that I have all of my information, I'm going to graph my function, and then I'm actually going to be able to compare and contrast it, or compare it, I'm sorry. So x is 0 and y is 3, so I count from 0, which is my origin, 1, 2, and 3 spaces up. So, wow, let me get a different color because that shade of green, you can barely see it. Let's see if this one works. Okay, this one's better. So 0, 3. So then I'm going to count one space to the right, meaning that my ordered pair is going to be 0, 3. And then, I'm sorry, give me 1 second. I just realized I made a mistake here. So this is where my ordered pair is going to be. And then what I'm going to do now is my slope is 1. So that means I'm going to count one space up. Let me just fix this here. So I'm going to count one space up and one space to the right. And this is where my other graph is going to be. Notice how it does not pass through the origin like y equals x. So that would be the difference, is that y equals x plus 3 does not pass through the origin. Eesh, that was pretty bad. Let me see if I can erase that. Okay. So it does not pass through the origin, or the origin, of course, I mean 0, 0. It does not pass through the origin. And so this is y equals, actually, let me write it over here. So y equals x plus 3 and y equals x. So the difference is that, well, y equals x plus 3 has a y-intercept of 3. Y equals x has an x-intercept of 0. This is why it's yx. The slope is the same because it's 1. And it's just that this one and the graph of y equals x plus 3 does not pass through the origin. So that's pretty much how you graph it. Let's go. I'm actually going to clear my drawings, and we're going to graph another function. Now we're going to graph the function of y equals negative 2/3 x. Give me 1 second. So y equals negative 2/3 x. I believe is negative 2/3 x minus 3. Let me see if let me just y equals negative 2/3 x minus 1. I'm sorry, minus 1. So we're going to graph this function. We don't have to compare it to anything, which is why I raised the y equals x. All we're going to do is just get the information. So the information, the slope, is negative 2/3. Now in your book, technically when there's a negative sign in the fraction, it applies to the entire fraction. However, because we're graphing, we're going to leave the negative only up on the numerator, which in this case is negative 2. So of course we know that negative 2 is y and that 3 is x. That's why we have it as a representation of y over x. And then our slope in this case is minus 1. So what does it mean when the slope is minus 1? Remember that in a y-intercept, I'm sorry, what does it mean when the y-intercept is minus 1? Not the slope, excuse me. So what does it mean when the slope is minus 1? It means that x is 0. So the ordered pair that we're going to have for this case specifically, let me get my marker, is actually 0 and negative 1. So now that I have that, all I need to do is just graph. So again, 0 is my origin. Let me see if I can change the color. Let me use red again. Or you know what? I'll use pink. 0 is my origin. And 0, negative 1 means I'm going to move 1 unit down. Now that I have that, what I need to do now is graph my slope. Now, if I look at my slope, here I get a fraction. And when you have a fraction in your slope, it's actually easier to graph. So the y just means that from the 0, -1 that I graphed, I'm going to count 2 units down. So that would be 1 and 2. And because the x is positive, that means I count 3 spaces to the right. So here's where I graphed my 0 and -1, right? Then I moved 1, 2 spaces down. I move 1, 2, 3 spaces to the right. And then this is where my other ordered pair more or less would be. And all you guys do after that is just connect the dots. And you have your equation for y equals -2/3 x minus 1. So this would be y equals -2/3 x minus 1. And that is example number 2, the one that I just did on page 90. And the exercises that you have to do are uploaded to your LMS, but just as a reminder, our problems 5 and 6 on page 90. So guys, hopefully this video is helpful to you guys. So stay safe and we'll see each other in our next class. So bye-bye.